What's up, guys? It is me, Expert here. Now today, I finally was able to problem solve one of my codes that I was trying to create. As we look up here, open any process by just typing the window name. You automatically open the process. You get the window handle. You get the handle to the window. You get the handle to the process. You get process all access. You can even edit memory by just typing in the memory address. Now this is good because you can just literally debug any process you want. You can find out what process needs permissions, needs better permissions, or what processes that you cannot use externally because of maybe certain keys that need to be typed into the window. But regardless, we're going to start off by going into the solution. We're going to configure this. Let's wait for this to load up. Okay, let's make a release. We're gonna do x64 because it's much easier. We're gonna do release. So let's do that. Now let's create our base our base file. We're gonna call this open any process.cpp. Now, while this is happening, in the background, you can't see it. Well, you can kind of see this part, but I'm going to create a new text document to demonstrate it. I'm going to call this test. So this will be our demonstrate here. This is the window name, test.txt-notepad. Alright, so let's go on with the code. This is a bit lengthy, okay? This code is going to take a while to type. I'm not releasing the source code on my GitHub for the one, because I am creating a new application here, and I have the one that I created in GitHub, which is much better than what I'm going to demonstrate here. But first we're going to do the basic includes. We just need IO stream, and we just need windows.h. We don't need nothing else. For the sake of time, we're going to be using namespace standard. So what we're going to basically do here is we're going to use a class function, okay? We're going to use this class function to get into the process. So we're going to call this class external, okay? So this will be our classes. So first we're going to put void setup, okay? We're going to call this we're going to call this void setup. Alright. Now, what the parameters for setup, we're going to have a lpcstr wind name, which stands for window name. We're going to get handle to the process, which is hand. dword for the process ID. We're going to definitely need int the right value, and over here I forgot to put this dword 64. We're gonna call this hexmem. Okay, so this is the parameters you want. Now we're gonna create the definition over here. So to create the definition for a class, you just have to do the following, and then we're gonna copy this. We're going to paste that right in there. Okay, so now we have the definition. Now, I know there's an error. I'll fix that in a moment. All you have to do is go to here, make this class set public so it can be accessed out of its brackets. So now, no more errors. Now we can do the definition. So first, we're going to have int read value. It will equal to 0. Okay, and we're going to have hwind handle window. We're going to make this a null parameter. Now we're going to do hwind equals get window I'm sorry. find window A. So this sphere will have, this will be null, no parameter, and then we're going to get the win name from a user input. So this will be user input, this will be user input, okay? So the hex mem and win name is user input. So since this is definitions, this is going to compile because basically from integer main, once we define the parameters here, it's going to go on to external setup, and then it's just going to automatically pull whatever we inputted to it. So once that's done, we can do some error checking. If Hewin, and then here would be else could not get a handle to window. Now guys, error checking is super important, or else you won't know what if it's successful or not. So next we're going to do hand, which is already defined. Okay, hand equals to oh, I'm sorry. First, actually, we need to do get window thread process ID, and this is going to be Hewin. And with Hewin, we're just going to do PID. Oh, and the address of PID, so it copies it to the address. Okay, so then now the error checking here is if PID does not equal to null, then over here it will be else could not get default process ID. We're going to do a namespace right there. Okay, so to start off, we're doing the basic external functions to get into the process. We're using find window A. We get into the window, and then we get the window thread process ID, so we can get the process ID from a thread, and it's just going to basically copy the memory that we get from here into the PID. So now our PID is now the process ID, and if process ID isn't the default process ID that was pulled from get window thread ID, then we didn't get the process ID, which that usually will never happen. If we get, as long as we find the window, this should never be a problem. So now we can move on to hand equals open process underscore all underscore access. You can make this true if you want to. All of your handles will inherit the process all access. That's up to you. And we're going to use the PID. Now error checking here. This is a very important error check. If we do not have a handle to the process that gives us process all access, then it could not get access to process. Okay, so we have our basic setup here. Alright, the setup is basically done. So now we can just do read process memory, hand, and then out of hand we're going to do a byte. I'm sorry. And this will be hex mem, so we're going to read the value of hex mem, and it's going to be read value, and it's going to turn it to the size of read value. And we're going to end it off with a null pointer. So it's just going to read the default pointer for the hex memory. So that's going to be that. And then for the write value, it's going to be write process memory, hand, byte, hex mem, and write value, and turn it to the size of write value. That will also be a null pointer. Alright, so this is the basic setup. So I'm going to add one more error checking here. It's going to be double error checks. Well, actually only one error check. So we're just going to do the null handle. I'm pretty sure we have to put an L. And then this says we are in process, just to check. Okay. And we're going to status success, and that's going to be null. I'm going to copy and paste this right here. and we're gonna call this the memory has been modified. Alright, so now we're done with the setup, okay? Now we can move on to Ninja main. Now this is going to be, we're not done with the setup yet, but we are going to define stuff over here, which will be very important. We're going to define hand, and this will equal to null. We have to define dword PID, this will equal to null, and dword 64, we're going to call this membase, and this will equal to null. Alright, next. So, we're going to have to add lpcstr wind name. Now we don't have to worry about defining that. Instead, what we have to put up here is a char. We're going to call this char input, okay? And we're going to make it a array size of 100. So basically right here is we're going to do a cout enter window name. So basically we're going to send for input, okay? We're going to send for input. So say input, and then I do, let's see, what is this one here? Basically in the console input, it would be test.txt-notepad. Okay, this is the window name. Alright, so we're going to send for that. Alright, and then once we find the window name, then we're going to put win name will equal to input. So now lpcstr win name, which is defined right here. So char input will then become lpcstr win name, and this is where we find our window. So this is where you can literally put anything you want. You can input anything you want, and it will find that window as long as the window is correctly named. If not, it's not going to find it. Alright, now we're going to do enter value to write. Now this is where we're going to add int write value. We're going to default make this a 0. If I did some testing with it, and if you include the int parameters inside of the setup, it's actually going to double the value. We don't want that, so we're just going to leave it in main. So it's going to be out of order, because usually you would want the window name, and then you want to enter the memory address, and then you want to write to that memory address. But instead we're writing to it before we even find the memory address, which it doesn't really matter. It doesn't make a difference, and it's actually better. So we're going to send for write value. Okay, and then now once that's done, now one more thing, I'm sorry, we're going to do external func. Alright, we'll just do external function. Alright, basically this command here, okay, this is our class. Our class is external. The only way we can access this class is if we make a function that will allow us to actually use the class, because if we do external setup, this is not what we want, because it's actually going to redefine this right here. Instead, we're going to want to use external function, which we just defined right here, setup, and then we want to put our parameters. So this is going to be win name hand PID. We should probably call this hexmem. Oh, hexmem, and then write value. Okay, so we can do a quick compile. It should compile successfully. Alright, it was successful. So basically, after we get the input for window name and the input for the right value, it's going to take us to the setup here, and it automatically shoots up to this code right here. Now we're over here. Now we need to add a few more things to this in order to complete it. The first one's going to be dword64 read base. Okay, this is going to equal to 0x0. We're going to want that to be 0x0. Okay, now over here, when we're in the process, we're going to do count enter memory address. Okay, now we're going to send for read base, send hex read base. Now the reason why we're adding hex is because if we just, so here's what like a standard memory block would be like. It would be like 0x blah 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 blah, but it would have like some words that's A through F because it's hexadecimals. It would be something like this, and if you were to put that into the console, it's not gonna know what the fuck to do with it, so you don't want to do that. So we're gonna read it as a hex value, so we don't have to put 0x. Usually you would have to put 0x and blah blah blah, that's your hex value. You just have to type in the letters and that's it. So once we read the base, okay, then hex mem will then equal to read base, and then this is where we start editing hex mem. So now I'm pretty sure we can start. We can do it now. So I'm going to open up test.txt. We're going to launch the debugger. And while that's happening, we're going to get cheat engine to open up. Alright. Now let's go to test.txt. Oh, give me a second. I actually want to set console title. I'm gonna call this open any process by expert. Okay. So now when we run this, the console title should have open any process dash expert right here. Open any process dash expert. So now we're gonna enter the window name. So the window name, we have two of it. It's gonna be test.txt-notepad. So we're gonna test.txt-notepad, and we already have an error, which probably because win name. Wait, let's run this again. Oh, we probably don't have the permissions to actually open up the window, so instead we're gonna open up the project from where it's at. It should be up here. Okay, so we're gonna go to x64, open any process, we're gonna run this as admin, and then it's gonna be test.txt-notepad. Actually, that was not supposed to happen. We should do a little bit of checking real quick. But yeah, it's. Oh, okay. Wait. I see why. Here, we're gonna have to pause it right here. System. Yeah, we're gonna do system pause. Yeah, we are not getting a handle to the window, which is weird. Yes, this code is correct. It should literally be running. Okay. We're just gonna save this right here. Test.txt dash. Okay, yeah, we're not getting a handle to the window. See, error checking is so useful. Now, there is definitely a reason to this. Now, it's probably because that we can do one error check here. Here. Cout input. So we can do test.txt dash notepad. Okay. My apologies, guys. I know exactly what's wrong. Okay. The reason why it's not working is because when you cannot have spaces in something like this. You cannot have spaces. There cannot be any spaces. I forgot about that. So what we have to do is send.getLine, and then we're gonna do input and size of input. Okay. Now this should definitely work. I can guarantee that this will work now. I'm sorry for wasting your time, but now this should definitely work. Alright, so we are in the process now. I did not get the message box for some reason, but we are definitely in the process, that's for sure. Yeah, there's no message box, but regardless, we are definitely in the process. Let's search for a value. So we're going to search for 12. We're having some addresses here. So we're going to write, first we're going to copy this. Okay. So let's write 1337 to the memory address of 780. Alright. So, as you can see, the memory has been written to. Now, basically what happens here is you're getting okay. So first, on accident, I had a sin. I didn't have sin.getLine. I only had sin, which is why we weren't getting the window title correct, which is my bad. But basically, we get the title name, then lpcstr win name turns into that title name, and then we find a value to write, so we can literally have anything we want. Then it moves on to external function. Now we start off here, and it goes all the way down. And before this code even executes, so let's move this right here just to help us out a little bit. Let's move that like that. Oh, I'm compiling. Oh, my bad. Anyways, so now let's run it again. Now the message box should pop up before this code even runs. So if we do test.txt-notepad, oh wait. Okay, alright, I got it. So test.txt-notepad. Okay, and we're going to enter 1337. We are now in the process. Okay, so now we get to enter the memory address. Now let's just pull another one. We're going to pull this one right here. Let's go pull this address. Now we're going to enter this in there. And as you see, the memory got modified. So we are definitely, and this isn't even using administrator. This code is literally working without administrator, which usually you would want administrator so you can get that process all access. But I guess Notepad doesn't really give a fuck, and they're just letting you get a handle to it regardless. Now, now how am I reading the hex values, which is the most important part of this code, was reading the hex values. So let's get back to that part. We're gonna fuck it 69. Okay, let's go back. Let's find a different memory address. Alright, so here I was stuck on this problem for at least a mere 4 days. I had no idea. Nobody, not even Stack Overflow, was telling me how to do this. But basically, I wanted to input the memory address, and I wanted the dword read base to read this memory address as a hexadecimal. And then for hexmem, which is this, I wanted hexmem to turn into the address that read base has read. Okay. Then that's when it reads the process memory for that address and it writes to that address as well. So I was having a problem with that. Now, the only problem was that I'm guessing that when I was trying to send, I wasn't sending with hex. Not only was I not sending with hex, but I wasn't even this was like this was a null parameter. I had it at null, which was not good. We want it to be 0x0, and after I put it to 0x0, it started to work. So yeah, if we just input this memory, we look here and it's 69, so you know it's working. So now let's move on to more stuff we can do. So let's do void contiguous. Oh my, I suck at spelling this. Contiguous memory. Okay. Now, the thing about this is that we're gonna have to redefine everything that's up here except for the right value. I mean, actually, we probably would want the right value. So you could do this two ways. You can read it as its own memory, or you can actually just write it as a value for itself. So since these are class functions, this handle, once this code is over, this handle and this handles right here, handle to the window, handle to the process, they automatically get closed out. Once we have read this whole code here is gone, is no longer working. So basically what this means, you're gonna have to do this again. So if we just grab this code here, this won't affect us memory wise. I'll show you why once I run the debugger. We'll literally only be capping out at like 3 megabytes at most. So let's create the definitions here. Void external contiguous memory. We're just gonna, actually I should have copied this first. And then we can copy this right here. So yeah, it's running the same exact code, but instead here we're gonna remove the memory is now, we can put this as now contiguous memory or contiguous memory, it's going to keep on staying the same value, and if the value changes, it's going to go right back to the value that it's supposed to be at. You could use virtual protect. Alright, you could literally make the memory, you could turn it into a read-only address, which you could use for contiguous memory, but since we're not using this, I don't really suggest this because this is kind of advanced stuff for virtual memory. We're not going to go with that. Instead, we already are going to be in the process, so we know that that's working. We just have to re-enter the memory address. Now you can either use the same memory address or you could use a second one, it doesn't matter. Basically right here we're going to read the value. We can either read it and that's it, or we could write to it, and then once we write to it, we could have do this. So right here it would be, we would actually remove system pause. Okay, so we're going to do a while loop, and over here we're going to add I equals 0. So while 1 plus I, because we're not modifying values, if hexmem does not equal to right value, Okay. And then we're gonna do write process memory to the cell right there, and then right here, if we want to get out of here, get a sync key. Oh, get a sync. And this will break the function. Once this breaks the function, we're gonna actually let's bring back system pause, because we are gonna break the function. Okay, so and then right here we're gonna sleep for I'd say 100 is good. 100. So this is about 1/10 of a second. 100 is 1/10 of a second since it's milliseconds, and 1,000 milliseconds is a second. So right here, this is the while loop. It's gonna check if hex memory does not equal to the right value, then it's gonna change it to right value, and if get a sync key state is BKF12, then it breaks this whole while loop. So this is now contiguous memory. We can run it, I believe, but first we're gonna have to, because once this code ends here, it's gonna go back to the integer main. So what we have to do is do you want to do, and then right there, end the line. Alright, now here we can do external function. Actually, my bad. We're gonna get a second input 2. Okay, and this will be if input 2 send input 2, if input 2 is equal to 1, then and then else would be system pause. Actually, yeah, it's input, it's correct. Okay, so if input is equal to 1 in char, it's going to do external function dot contiguous memory, and this is where we just redefine win name, hand, PID, hexmem, right value. Okay, now that should work. So I'll show you the meaning of contiguous memory. Now if this runs correctly. Alright, so now we're going to enter test.txt-notepad. We're going to write the value. Let's just do, for sakes, 3,450. Okay. The value is 3,450. So let's scan for a new object. Okay, let's take this address. We're going to enter this address. Alright. Modify the memory. It's there. Okay, now, do we want to do contiguous memory? We're going to say yes, and then we're going to enter the memory address that we just pasted in, and this memory should now be contiguous. Now what this means is if this value if it changes, it's going to go back to 3,450. So let's try it. As you see, I'm changing it now. Okay, as soon as I click OK, it goes back to 3,450, meaning that this value will never change. It will always be going back to 3,450. Now that's how this memory is contiguous, and it's going to last forever until you break the while loop. The while loop is right here. So this code is going to be forever running until you break it. And as you see here, like I said, the process memory, we're only using maybe 2 to 3 megabytes at max, which is good. So this memory will forever be contiguous. It's never going to end. But if we press F12, okay, and we break this statement, this will no longer be contiguous. Now let's run the example one last time. We'll do one more example. If you guys don't understand, we're going to take this memory address. Okay, we're going to do test.txt-notepad. And we want to say, let's write 9,200, whatever, okay, blah, 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 whatever. Alright, now we're going to enter this memory address. And you see, it's the same value we inputted here. Okay, now we're going to turn this memory in contiguous memory. Alright, which I accidentally closed it out. I'm sorry. Let me do this one more time. Fine, let's do 1337. We're going to enter this memory address. So now it's 1337, and then we're going to put 1, and then we're going to enter the memory address again. Now it's going to be contiguous. So if I change it, now it's not going to work, buddy. It's going to go back to 1337 no matter what. Yep, that's how it's basically going to work. You can change it as much as you want. It's never going to change unless you break it. Once it's broken, boom, you can change it however much you want. Okay, so yeah, this is the thing I was having trouble with for quite a long time. The basic part was just trying to get to read the address that I want to edit, because it was not working at all, but I finally got it to work. So yeah, this is the code. I will have the GitHub link in the description if you want to use mine. It has contiguous memory. You can edit memory. You can also, there's a trigger bot function that I need to work on. You just have to input whatever memory base that you want. Alright, and then it's just gonna give you trigger bot basically. That's all you need. So yeah, that's gonna be it. Thank you for watching.